Good evening, everyone. Myself Sandeep. Okay. Today I'll be explaining about how the RAG evolved. Okay, the evolution of RAG and what are the components of RAG and the architecture of RAG and how we overcome the limitations of other components to come across RAG. Okay, I'm sharing my screen. Today we shall see the process of evolution of RAG. First, before moving to RAG, we'll understand what is artificial intelligence or what is generative AI, what is the difference between traditional AI and generative AI, and what limitations we have in generative AI and why we needed RAG. Okay. First, for example, artificial intelligence. Artificial intelligence is nothing but is a branch of science where we mimic human brain. Okay, branch of science where we mimic human brain. Mimic human. Okay. Okay, we are making machines to do the task which are done by humans. Okay, in or artificial intelligence, or we can also call it as traditional AI. Traditional AI. When you see this machine learning plus deep learning or NLP, okay, together we call it as data science or traditional AI. Together, all these components or these techniques, machine learning, deep learning, NLP, together we call it as data science or traditional AI. Now, we'll understand what is traditional AI. It's a branch of science. Okay. Now, for example, it's a artificial intelligence which mimics human brain. For example, I'll take one data science model. For example, I'll take one data science model. I'll take one data science model. For example, now I'll consider this data science model is trained on, for example, Python. Okay, this data science model is trained on Python. For example, now for this traditional AI model, okay, the Python model, if I ask what is Python, okay, it will give answer. Python is some programming language, etc. It will give answer. Next, what are data types? It will give. If I ask one more question, now it will give. Now, if I ask what is Java, now, okay, now this traditional data science model or traditional AI model is trained only on Python. So, if I ask any questions apart from Python, even though it will give answer, what type of answer it will give? It gives us the repeated answers. Because we don't know what is Java, it is trained only on particular to Python, so it gives us repeated answers. Repeated answers. Okay, whatever question we ask apart from Python, it will give with answer with respect to only Python. That are repeated answers or wrong answers. Entire together we call it as hallucinations. Hallucinations. The meaning is traditional AI model, or for example, in this case, I'll take one more example here. For example, I'll take 3 years data science model. Now, okay, this is just a 3 years old kid we can consider. If I ask, what is your name? What is your name? The kid can answer. Or what is your father name? The kid can answer. Or mother name? The kid can answer. Similarly, if I ask, what is your school name or what is your mathematics? The kid don't know that answer. Why? Because the kid has limited knowledge of knowledge. So whatever question we ask apart from that knowledge, the kid may repeat the answer. The kid may give the repeated answer whatever the kid knows. These we call as hallucinations. Okay, now here, so it gives a repeated answers that we call as hallucinations. Okay, now what does it mean is traditional traditional AI models can give traditional AI model can give responses only on the data it is trained on. Only on the data it is trained on. Only on the data it is trained on. So these traditional data science model or traditional AI models can give responses only on the data it is trained on. For example, in place of Python, if I take physics, okay, now this model can give all the responses with respect to physics. If I ask any question apart from physics, it may give wrong answers or it may give repeated answers. These are this is meant by traditional AI, or these are the limitations of traditional AI. Now, to overcome the limitations of traditional AI, we have new technology. Sorry, we have new technology called generative AI. Nowadays, you may heard about this generative AI. It is a trending where everywhere people are saying that generative AI, agentic AI, everything. Okay, I'll show you the what is a gap between the generative AI and agentic AI and traditional AI. Generative AI, it's a part of artificial intelligence where the data is trained on entire public data. It is trained on it is trained on entire public data. Public data may be it may be entire internet, Wikipedia, or articles, newspapers, etc. Whatever data it is available in the public, whatever data it is available in the public, that are called as public data. So these generative AI models are trained on entire public data. Okay. Now these generative AI models we called as LLMs. Okay. For example, we know ChatGPT, okay, Gemini or other organizations GPTs or LLMs. Okay, these LLMs are nothing but large language models. Large language models. Why it is called large language model? Because it is trained on vast amount of data. It is trained on vast amount of data. So it is trained on entire internet data or entire public data. That's why it is called as LLM, large language model. So now I'll take one generative AI model. Similarly to data science model, now I'll take one generative AI model. For example, I'll consider it as LLM or ChatGPT. Now we can consider this ChatGPT as one LLM. Now if I ask for this ChatGPT, now this ChatGPT is trained on billions of parameters on entire internet data, public data. Now I'll ask, what is Python? Okay, it will give the answer. Because in internet we have the information related to Python, or what is, for example, what is Java? It will give. What is data science? It will give. Okay. Now whatever question I ask, it will give. This is generative AI. Again, in this generative AI also we have some limitations. I'll come to that point later. See here. Okay, this is traditional AI. It works on the data it is trained on. For example, if this is any traditional AI model, for example, if it is trained on any fruits or vegetables, and if I ask any question related to fruits or vegetables, it may answer. Apart from any question, it may give us repeated answers or irrelevant answer or incorrect answer. This is what traditional AI does. Now, I'll take generative AI. Okay, along with the answering the entire public data, this is able to create some new data. New data may be text or video. Why? Because it already learned the data as well. Okay, traditional AI and generative AI. Traditional AI can give, along with giving the responses, it can also create some new responses. Responses may be text, image, or video, etc. Now, here, if I take LLM as one ChatGPT, these LLM or ChatGPT is trained on entire public data, which means billions of parameters. This ChatGPT is nearly trained on 175 billions of parameters. And if I ask any new question, okay, if it is Java or Python or what it may be, biryani or any country or any information in the internet, it will give us responses. Here, okay. For example, this LLM is called as large language models, which are trained on entire internet data or vast amount of data. Now, user, if ask any question to this LLM, along with the query, we also add some prompt. Prompt is nothing but just an instruction which is given to LLM. Okay, this is the language where LLMs can understand. Along with the prompt, we also give the user query so that okay query can understand. Okay, LLM understand that query and it results to the query, or it gives the response to the user. This is what generative AI work, and this is how generative AI work. Now I'll open one LLM. We'll see practically. For example, I'll open ChatGPT. I will told that this is a LLM. So first I'll ask, okay, what is Python here? I'll ask. Okay, now I'm going to internet. Now, if I search answers in the internet, I'm getting answers in the form of web pages. Now, each and every web page, for example, W3 schools. Okay, this web page consists of information related to Python. Again, okay, for example, one more. Okay, Amazon Web Services. Okay, here if I search anything in the Google, so I'm getting answer in the form of web pages. So I'll search same answer in LLM. We'll see how the response will be. So I am searching what is Python. See, now you can see I am not getting answer in the form of web pages. Instead of getting answer in the form of web pages, I am getting one structured answer. Structure redefined answer. Okay. Now why? Because see, this LLM is already trained on this web page data, this web page and all this web page. Why? Because it is already trained on entire internet data. So instead of giving answers in the form of web page, it is giving us a summarized answer. Summarized answer. See, for example, I'll ask, okay, give me in 100 words. Is that it will give us a summarized answer. See, now I'm getting only in 100 words. Now I'll ask one more question. What is data science? Again, it is giving us answer. Because these data science, okay, it is already the information is already there on a website or internet, so it may able to give the answer. Now, again, as I told, again we have with respect to generative AI. Okay, now I'll take this same LM. Now I told that LLM or entire internet data, but these LLM trained on private data in company internal data or like projects. So our personal data or employee details, whatever. Okay, this LLM is not trained on private data. Now, if I ask LLM also gives the answers in the form how this traditional AI has responded, gives the hallucinations or repeated answers. These are the limited data, or okay, this LLM won't be having the current data like news, stock market, stock information. This information, stock information or news with respect to politics or finance, it will be changing day by day. So this information won't be having with the LLM. See, these LLMs we need to frequently try. For example, if I take one LLM, if I take one LLM, it is trained till okay, trained till December 2025. Okay. Now, if I take this LLM will be having only information till December 2025. If I ask any question after, which means that 2026, this information won't be having. So we need to frequently train this LLM. Next, hallucinations, giving the wrong answers, or repeated answers, or generalized answers. So okay. Now we'll test. Okay, if I ask some private data, okay, how this LLM will respond, we'll see. Now I'll ask, for example, I'll ask my name. What is the, for example, what is the salary of Sandeep? Okay. Now see, it is telling that I need a bit more information to answer this. Sandeep could maybe many people. Okay, see, the personal data of me is not there with the LLM. Okay, no personal data. is not exposed to this LLM. Okay, I'll ask one more question. Now it is not giving. For example, what is the company leave policy of Zepto company? I'll ask Zepto Corporation. What is the company leave policy? See here. See, this this is a personal data. This is a personal data of Zepto organization. So, okay, it doesn't have the answer nation. So, instead of not giving the answer, it is giving the generalized answer. Here you can see, yes, what generally known about leave policy of Zepto, Indian quick commerce, typical leave entertainments, etc. See, it is giving us the generalized answer. So, this personal information is not there with this. These are the limitations. For example, if I ask, what is okay. Okay. What is it? Infosys next project. Also, it may not have the future data. Infosys next project. This okay. See, it is giving us the generalized answer. Why? Because it doesn't have private data. These are the limitations with respect to LLM. So, to overcome the limitations with the generative AI or LLMs, we came across new techniques called a RAG, Retrieval Augmented Generation. Retrieval Augmented Generation. What it this RAG does is, for example, we can consider this LLM as brain. For example, I consider this LLM as a brain. Now, this LLM is already trained with the entire internet data. It's already having the ability to summarize data, generate new kind of data, understand the content, understand the grammar, etc. Along with this, okay, the only thing it is lacking with is private data. So, along with this, I also give some private data. See, instead of training this LLM from the scratch, what we can do is we can fine tune this LLM for our specific task. Again, training this LLM from the scratch, it is cost effective. Okay, training from scratch, again, it is very costly or time consuming. For example, if you want to train one LLM from the scratch, again, we need a team, we need supercomputers, a research team, supercomputers. Okay, then cost, again GPU. Okay, we need lot of things. For example, it may cost in crores. Okay, it may cost in crores. Instead of training from the scratch, what we can do is we can fine tune this LLM for a specific task. This is called run. Already it has some data. So for that brain, I am giving some external data. So whenever I ask some question to this LLM, if it has the answer, it will answer, or else then it will search from the private data. You can consider this as book. Already, see, this brain has some answer. Okay, if it has, then it will give the answer. If not, then it will open. Now I'm giving the private data information. It may be any this we call as knowledge base. This we call as knowledge base. It may be any database or website or anything. So it will look in this and then it will answer. It's same like, see, RAG is like open notebook exam. RAG is like open notebook exam. I'll go and explain. I'll take one scenario. First scenario, student writing answers from his own memory. Okay, when student write answers from his own memory, there is a chance that he can write wrong answers. There is a chance that he can write wrong answers, repeated answers, or okay, I cannot believe. I cannot. It cannot. Okay, we cannot believe the answers. Believe answers. Okay, these are the issues if you having, if it answers from your own brain. Second scenario, the student answering by looking at the book. By looking at the book. In this case, if the student don't have the answer in his brain, you will look at this book. You open the book where information is present. You will look at that book and in separate page. Then you will answer. So in that case, in second case, I can, okay, the answers are reliable. Answers are reliable. Why? Because he is looking at the book, so I can trust that answers. I can trust that answers. The answers may be accurate. The answers may be accurate, etc. Okay, RAG is like a open notebook exam. So now I'll explain the architecture of a RAG. In simple, see, for example, you can consider this as an LLM. Suppose if user asking some question, if user is asking some question, if it has, if the LLM has that answer, then user get the answer. Okay, the process is done in a small, simple step. For example, if the answer is not having with the LLM, then we come across a topic called retrieval augmented generation. For example, this is my external database or this is my personal information. This is my personal information. See, as this is just a demo, I won't be explaining what is the technical thing. This embedding generation, embeddings, vector stored database, these are technical terms. Okay, I just give overview of RAG. Okay, if you are really interested, then we can okay, study this RAG in our regular classes. Okay, now you can consider this is my personal data. This personal data is stored in the vector database. Database is nothing but simple. We are converting this external database or knowledge source, also called as private data, in the form of zeros and ones. Why? Because machines can understand only binary language. So what I'm doing, I'm storing this information in the form of zeros and ones in the vector database. You can consider this vector database as one large bucket. Now my private data is present in large bucket. Now, if the LLM is not having the answer, then this LLM or my retriever, okay, we'll be having one component called retriever. This retriever will search the data in this database. If I get the answer for the user query, okay, the retriever extract the information from this large bucket or database, and then it will give that answer to the LLM. Also, the retriever extract the top results and then it will give the answer to the LLM. The LLM summarize that answer and then it will give to the user. If the answer is provided with the LLM, then it will give, or else then it extract from the external knowledge base. This is called as external knowledge base or private data. These are the components of RAG. Okay, external knowledge source or private data. This we call as, okay, that means the LLM from which it is answering. Retriever is responsible for extracting the information from the vector database. Large language model, okay, it understands the user content or grammar or answer. Next, prompt builder. Okay, here this is one component. Using this component, I am controlling the behavior of LLM. Why we need prompt is because, okay, if without prompt, the LLM may give the wrong answers or repeated answers or hallucinations. To control this LLM, I am adding this prompt. I'll show you here. See here. This is the code. Okay, this is a practical example of RAG. Okay, I'll explain you in further classes. This is just demos here. I am adding prompt to this LLM that you are an assistant. This is one of the application where multi-PDF RAG chatbot. Okay, I'm building that chatbot can answer from any question from any PDF. You are an helpful assistant. Answer only from the provided context. Here, with the help of chart prompt template, I am controlling the behavior of LLM. If the answer is not found in the context, see, answer only from the provided context. I am telling the LLM that, okay, whatever content you are given or whatever the text or whatever the document you have, answer only from that document. If the answer is not found in that document, say to the user that I cannot find the answer in the provided content. Here, the behavior of the LLM I am controlling using chart promptlet. Okay, if I am not adding chart promptlet, the LLM may give wrong answers or it's hallucinations. Clear? No. These are the components of RAG. Now I'll practically see. This is one of the application which is RAG chatbot. Okay, or any PDF chatbot. Now I'll open this application. So this is my application. Now I'll upload my personal data or PDF or any, you can consider any PDF, or for example, I am uploading this document. Okay. Also I'll open this document. You can see after I'll process that PDF. You can consider this PDF as a personal data now. Now it is posting. Now it is converting all the text present in the PDF and it is storing in the vector store database in the form of zeros and ones. Now I'll open this document. You can see this is the document I think I uploaded. Example, this document consists of 70 plus pages. This document consists of 70 plus pages. So I'll ask some questions in the from this document. I'll ask some questions from this document. Okay, now I'll ask. Okay. I'll ask what are the challenges and opportunities. What are the challenges and opportunities? Now these Now, see, this chatbot should answer only from the provided context. See, it will answer based on the provided context. The challenges and opportunities are listed below. These are the challenges and these are the opportunities. See, challenges, you can see market volatility, regularity hurdles. See, it is answering from this website. See, here I am controlling the behavior of LLM that it should answer only from the provided context. If you're not having the answer, now am I getting the same answer? See, okay, I am getting the answer from the provided context. This is my provided context. See, also I'll ask one more question. See, yeah. No, you are okay. If the answer is not found in the context, say that I cannot find. Now I'll ask one irrespective answer which is not provided in the document. I'll ask what is the salary of Sandeep now. See, now for this question, the LLM doesn't have answer. In this case, okay, instead of giving wrong answer, now my chatbot should give that I am not having the provided context. Why? Because I am telling that if you know don't have the answer, please don't give wrong answers. Instead, give the answer that I don't have the context. Look at here. What is the salary? Okay. See, what is the salary of Sandeep? Salary of Sandeep is not present in that document. It is a document related to some project. Okay. Now, see, it is giving that I cannot find the answer in the provided context. Here, I am controlling the behavior of the instead of giving wrong answers. But we know that LLM will give the repeated answers or wrong answers. So to overcome these limitations of giving the wrong answers or generalized answer, I have my own chatbot where it can read the company internal documents. Company want an LLM which should read its own internal document and it has to give or response to the user same as like humans. Okay, each organizations need their own RAG applications. For example, what happens? See, even in this we have ChatGPT, and for example, if I give that same document to this ChatGPT, it will give answer. What happens if I upload my personal data to this ChatGPT? It means then I am sharing my own company data with other company. Okay, then it is not reliable. So what I do is each company will have their own application to read their own company internal document. I'll ask one more question from this document. We'll see. Okay. Okay, who are the competitors? I'll ask who are the competitors. See, who are the competitors? The competitors mentioned are 5 Paisa, Capital Limited, Zero, the Upstock, Fires, etc. So I'll upload one more PDF. Okay, I'll upload. See, it is giving us provided answer. I'll upload one more PDF. For example, guidelines. This small PDF. Also, I'll open that PDF to show you. Okay, guidelines, right? It is just present in my local system. Guidelines. It is one of the student guidelines. I'll ask. Okay, what is the student? Okay, this is a certificate belongs to one student. Okay, okay, guidelines. Okay, I'll ask to summarize this, or I'll ask what is the paper size. Okay, what is the paper size? See, it has to give only this particular information, not all the information. This retriever. Now see, okay, so I need to give the guidelines. Here two files, right? You have two database or two external knowledge. So I need to specify. Okay, I'll for better case I'll delete this. Wow, okay, I did the mistake. I did not process this PDF. I need to after uploading that I process this PDF. Now it has processed. Now it will give the answer. See, understood why what is the error? I did not process. Okay, that's why it is given error. See, A4 size paper. See what is the answer? What is the question asked? What is the paper size in guidelines? You can see that in these guidelines they have mentioned that A4 size paper. Or I'll ask, give me the summary. Summary of the guidelines. See, it is giving the summary. The guidelines for the internship report to be submitted by sixth semester BCom student can be summarized as follows. The student should be continued in a conducted in a private company. The report should have 4 chapters. They mentioned the 4 chapters. You can see this chapter 1 in this chapter 1. Okay, the content is chapters, the first chapter, second. Okay, this is summarizing these chapters. Here the content is, or the length of the content is more, but here my chatbot is summarizing that and it is giving us. Then it is the rules and regulation. This is how we can overcome the limitations of LLM by using technique called RAG, Retrieval Augmented Generation. Okay, this is about RAG. Okay, thank you everyone.